implementing always-on availability groups. Always on, one of the hot new buzzwords in SQL Server 2012, and it's really just a fancy term for a couple of features that give us high availability and disaster recovery. One side, we looked at it in a previous nugget when we talked about clustering, and that's failover cluster instances. That's a way that we can get a couple of instances to look like one instance that fail over to one another. So they give us availability, high availability and disaster recovery at the instance level. Availability groups give us high availability and disaster recovery at the database level. It's also SQL Server's replacement, or really evolution, of database mirroring. So everything that database mirroring does, availability groups does better, and not to mention all the things that database mirroring can't do, availability groups can do. Checking out the nugget overview, we'll start by getting familiar with always-on availability groups. We'll get familiar with the technology, what it's all about. We'll talk about some terminology, things like replicas, primary and secondary replicas, availability modes, failover modes, and then we'll get a design going because we're going to take that design and actually put it to use when we get into a demonstration on how to set this stuff up. We'll also get familiar with the prerequisites. There are some prerequisites we need to be familiar with before moving on with always-on availability groups. The big one being it needs to be installed in a Windows Server failover cluster environment. From there, we're going to put this stuff to use and get familiar with how to create and configure availability groups. So I'll walk you through how to get this stuff up and running. We're not going to be able to use the virtual Nugget Lab for this specific nugget, but I do have a local machine here called Host Nugget that is really just a virtual host that I have Hyper-V installed on that we have 4 virtual machines, virtual instances running on. We have a DC Nugget to act as our domain controller, and then SQL Nugget 1, 2, and 3 to act as nodes inside of our cluster. We'll also take a look here at how to manage availability groups post-deployment, and at the end I'll show you how to work with availability groups by utilizing those read-only replicas. Show you how you can take your reports and point them at a read-only replica. So we can take all that reporting load off of our primary server, save that for transaction-oriented stuff, save that for our main applications that do the data entry. And not only that, but we can also take our backup operations and take those off of the primary database and put those onto our secondary databases or even our read-only databases. So I'll show you how to do that in applications, in reports, and I'll also show you how to do it here in Management Studio, because you can even connect to a read-only replica to test using Management Studio. So what are always-on availability groups? What do they do for us? And I think really to fully understand what they're all about, it's good to at least get a brief introduction to database mirroring. And now we do have an entire nugget dedicated to database mirroring, so I won't get super detailed here. But just a brief over, with the database mirror, we can take a single database. So take our production database, for instance, and we can create a synchronized copy of it. So this primary production database would be known as our principal database, and then our fully synchronized copy would be known as the mirror database. And anything that happens in our principal database automatically gets pushed over to our mirror database. So these are considered failover partners. And if something were to go wrong with the server that our primary or principal database is on, then they can switch roles. So our mirror then will become our primary, and then this, whenever it comes back online, will become our secondary. And we do all of that through manual failover in this scenario because we only have 2 instances working together. You can introduce a third one, and this wouldn't be a database, this would be a server called the witness server. And you can have many witness servers out there that are all monitoring your mirror, and that would support automatic failover. So if something were to happen to our principal instance, the witness could then initiate the automatic failover and do the role switching on its own rather than us have to step in and do it manually. So the big downsides to database mirroring is, number 1, we can only have one database in a mirror. And number 2, our mirror is inaccessible to anything outside of the principal. The principal is the only one that can send those transaction logs over. It's always in a recovering state, so nothing can ever access the mirror. So enter always-on availability groups. It works very much like database mirroring, only there's a lot more to it, and we have a lot more options available to us. So instead of we have these principals and we have the mirrors, similar, but everything is considered a replica, and a replica is just a set of databases. But we do have what's called a primary replica, which you can only have one of, very much like your principal, and then we can have up to 4 secondary replicas, which are very much like your mirror. On top of that, our secondary replicas can be marked as read-only. More on that in a little bit. So if something were to happen to our primary, much like our principal, we can switch roles, and our secondary can become the primary, our primary can become the secondary, and a lot of this is going to depend on the communication, how the communication between your primary and your secondaries occur, and the failover mode supported. So you'll notice these availability modes. We have asynchronous commit and synchronous commit, and that just determines how this line works in both database mirroring and availability groups. So we have asynchronous commit, which just basically means the primary database, when something happens to it, it's just simply going to send it and forget that it happened. Or not really forget that it happened, but it's not going to get confirmation from any of the secondaries that those transactions were hardened, were actually written to disk. And this is actually known as high performance mode in the database mirroring world. Now, what asynchronous commit mode is good for is those data centers that are geographically separated, because your latency will be low if the primary replica is just sending the transactions over rather than waiting for a response from your secondaries. Another thing about asynchronous commit mode is, as far as failover goes, it does not support automatic or planned manual failover. So it works best for those geographically dispersed data centers and for disaster recovery scenarios. Synchronous commit mode is really the opposite of that. It's meant for your high availability scenarios, and anything that happens on the primary replica must happen on the secondary replica hardened to the log first before it's then hardened on the primary replica. So if anything happens in between there, the entire transaction will get rolled back on all replicas. So that's why it's considered high safety mode, and that's also why we support automatic and planned manual failover. And just to go over some of these failover modes, automatic is just that. It means if something were to happen to our primary replica, SQL Server can automatically fail over to a secondary and do the role switch. Make that the primary, and everything will get redirected there. So this, we will suffer from no data loss. Same with manual planned. And this is if we need to take our primary offline for maintenance, then we can do planned manual failover. Again, no data loss. Forced is, again, for those disaster recovery scenarios with asynchronous commit mode where there is the possibility for data loss. Now let's talk about some of the requirements and components that make up availability groups. The big one is going to be Windows Server failover clustering. We need a failover cluster up and running, and that really applies to both sides of AlwaysOn. Availability groups and failover cluster instances are built right on top of Windows Server failover clustering. So once we get a cluster up and running, we can start adding nodes into the cluster, and it's a lot easier with availability groups than it is with FCIs, failover cluster instances, but you can still use FCIs in your availability group. In fact, you can even mix and match like we have here. We have 3 standard, and these you would just install SQL Server as you would, just a normal installation on a typical machine, and then you can just add that machine as a node into the cluster. Not much to it. As we saw when we talked about clustering, FCIs, there's a lot more than that because we have shared storage, and then we need to actually create a SQL cluster inside of the failover cluster. So there's a lot more to it. But again, you can mix and match these. You can have a replica in your availability group that sits on an FCI instance. You will lose some functionality, though. There's a couple of little things that aren't supported. The big one being there's no automatic failover for the replicas that sit on an FCI. You would probably only do that for those special circumstances where you need both high availability and disaster recovery. Now, a couple of the other major components here. The big one, obviously, is the availability group itself. It's an actual container that we can work with and configure. We can add replicas in. We can take replicas and databases out. All that kind of stuff we can do at the availability group level. Another big component in how all of these replicas communicate with each other is through endpoints. So each instance will have an endpoint configured on it, and the wizard will do this for us as long as all of our SQL Server accounts on each one of these machines is running under a domain account. If it's running under a non-domain account like local system or network service, then you'll need to manually set up your endpoints and configure them for certificate authentication. So if we were to leave it like this, we could get a availability group up and running. We would install SQL Server on a couple of nodes. We would create a cluster, add the nodes into the cluster. We could run the wizard to create the availability group, which would create our endpoints, and then obviously all the special things we could do with our replicas. But the thing is, if clients wanted to connect to a database right now, they would have to specify the server name that they were connecting to, so our primary replica, and they would be working with it. So developers would be hard coding their connection strings, and we, through Management Studio, if we wanted to work with that database, we would have to connect to that specific instance, know which one is the primary to work with it. We have something called availability group listeners, and a listener is a lot like putting a virtual network on top of all of our availability groups. So it'll have one IP address and one virtual network name associated with it, and it'll do all the management of routing the requests between the primaries and the secondaries. So if failover occurs, it'll know which one is the primary and to route it to that specific one. On top of that, we have what's called read-only routing. And this goes back to our read-only replica. So what happens is we can mark specific replicas as read-only replicas, and then we can point all the traffic that's intended for read-only operations to that secondary replica. And by the way, secondary replicas that are marked as read-only or that can accept connections and work with stuff is considered active secondaries. So in this case, an active secondary that's marked as a read-only, we could take all of our reporting apps and we could put in their connection strings something called application intent equals read-only. I'll show you how to do this in a report and in an application when we get over into the demonstration. And what that'll do then is the listener will notice that, and it'll reroute the request into our read-only replica. Therefore, all of our reading, all of our heavy reports can be offloaded onto our secondary replica, which is really nice way to take the load off of our primary. And then we can leave our applications that do data entry and transaction processing alone, and they will then use the primary replica. So all that's accomplished through the availability group listener. And for us in Management Studio, our applications and our reports and their connection strings, they're going to point to the virtual network name that we assign our availability group listener rather than to each individual server. So it's a much more dynamic way of doing things because, again, if failover occurs, the listener can do all the routing. Now, we're going to get into a demonstration and design an availability group. But before we do that, I just want to show you the design we're going to use. I've seen this in the field. I've seen this online a little bit, and I just think it's a great design. The only thing here is obviously everybody's environments and requirements are different, so it may not work for every situation, but it certainly is a great guideline to go by when setting up availability groups. So what we have here, let's say we have 3 servers, just like we're going to have in our demonstration. We're going to mark one as the primary. We're going to mark one as a secondary. Now, this first secondary is going to be a non-active secondary. We're not going to allow connections into it. It's purely going to be there, just like database mirroring, as our failover partner. It's going to have synchronous commit availability mode turned on. So that means the only thing that's going to have access to this is our primary. And they're going to do role switching because there's going to be automatic failover in between them. And that's good. Now, the next one we're going to have is our secondary that we're going to mark as a read-only, so we can redirect our reports here. Now, this is going to have asynchronous commit mode between our primary and itself, and in that way, we're kind of got the best of both worlds here. We have the mirror set up for automatic failover, and then we have our secondary read-only setup where the primary is just going to be sending them and forgetting about them, so it won't slow down our primary. And this is also great for training purposes and demonstration purposes because we get to see everything. We get to see asynchronous commit mode, synchronous commit mode, automatic manual failover, and even forced failover if we needed to fail over to our read-only instance for whatever reason. And then we're not going to do FCIs, but you can certainly set up an FCI, put a replica over there, and that will also have to be asynchronous commit mode because it's all it supports between your primary replica and anything that's on an FCI. All right, let's head over to our host Nugget machine here locally and learn how to create, configure, and manage availability groups. So here we are on host Nugget. And on host Nugget, we have Hyper-V installed, and I have 4 virtual machines running here, DC Nugget, SQL Nugget 1, 2, and 3. So those are all up and running. DC Nugget's our domain controller for the network, and then obviously these are going to be our nodes inside of our cluster. So I also installed Enterprise Evaluation Edition of SQL Server 2012 on each one of these. Again, just a standard regular old installation. It just has the database engine on it and not much more. So let's head into SQL Nugget 1. We'll do most of our work here from SQL Nugget 1. And I see I have SQL Server Management Studio already opened up here. And I did just default installations. So no instance names on them. Just simply SQL Nugget 1 is the name of the SQL instance on SQL Nugget 1. Same with 2 and same with 3. So let's click the Start button and head into our Failover Cluster Manager. And we'll right click and choose Create a Cluster. So we'll go through the wizard here. We'll just browse and add all of our machines into the cluster. Let's just hit SQL and check names so we can browse Active Directory. There they are. All 3 of our SQL Nugget machines. We'll hit OK. We'll hit OK. That'll add them as nodes into the cluster. And that's really all we need to do here. We can hit Next. In the real world, I would definitely advise running through the configuration validation test to make sure everything's set up. We're going to say no here. I know everything looks good, so we'll hit Next. Now we need an access point. So let's just call this here, how about our SQL AG-cluster. We can give it an IP address. Let's just call this one, how about 2, and hit Next. The next screen, just a little confirmation, just give us a brief overview of everything we just did in the first two screens. Looks good, so we'll hit next, and now it's going to create the actual cluster. There we go, cluster is created. If we hit finish, failover cluster manager will get us right into it. And there we go, all three nodes, all with SQL Server installed. But again, we didn't do this like failover clustering instances where we need to create that special installation of SQL Server where SQL and its applications would be installed as resources inside of here. We don't have to go to that extent. Just install SQL Server as you normally would on your nodes, and then create the cluster and add those nodes into our cluster. So we're almost ready to get availability groups up and running. The last thing we need to do is head into each one of our SQL nodes and into SQL Server Configuration Manager to turn Always On Availability Group functionality on. So you can do this into Configuration Manager, go into your services, right into SQL Server, your database engine service, right click, head into Properties, and you'll see a tab here for Always On High Availability. We will want to enable that. So once you do this, it will require a service restart, and also while you're over here, make sure if you do want to use a domain account so we can have the wizard automatically create our endpoints for us, then make sure that you're running under a domain account as we are. I made a domain account called sql.srv, and then every single database engine service on Nugget 1, 2, and 3 is running under that. I also then enabled Always On for those instances as well. So now we're ready to go. Let's head back down to SQL Server Management Studio, where we have a connection here to our local SQL Nugget 1. Let's expand databases. We're going to take these two databases, AdventureWorks 2012 and AdventureWorks DW 2012, and we're going to call this our replica. This is going to be our primary replica on SQL Nugget 1 to start, and then we'll get secondary replicas set up on SQL Nugget 2 and 3. And let's just get connections here to 2 and 3, just to show you what we can, what it looks like over here. There's 2, there's 3, and you can see we do not have the databases on here. And that's something else that we're going to need to do is during the synchronization phase, and that is where SQL Server, the initial data synchronization, was where SQL is going to need to take these databases and bring them up online over on SQL Nugget 2 and 3. And the best way to do this is to create a share out there somewhere that all of these have access to. And I actually did that. If we head down here, I'm just going to go into DC Nugget /backups. Here it is. So I made a share called backups. So that's the share we're going to use when we go through the wizard here to set it up, that we're going to point it to, so SQL Server can then take a backup, a transaction log backup, and then get it up and running over on our target machines where the replicas are going to sit. So to create an availability group, we can head up to the Always On High Availability node, expand that. Here we have availability groups. We have nothing in there, so let's right-click and walk through the new availability group wizard. Start screen, just give us an idea of what we're going to be doing through this wizard. Let's hit next. The first thing we need to do is give it a name. What do we want to name it? Let's just call this our Nugget AG, Nugget Availability Group. And then we'll hit next. The next screen is what databases do we want in the availability group. And you can see we can't check them because a full backup is required. So let's just head back into SQL Nugget 1 databases. Let's right click on AdventureWorks 2012 and let's do a backup. So we'll do a full backup here. And this is just going to go to DC Nugget /backups into our file share. And we need to give it a name here too. So we'll call this AW 2012. Let's just do AW.BAK. There we go. Keep it simple. So we'll say OK there. We'll say OK there. And this will do our backup for us. So that'll take a little bit to do. While that's running, let's do the same thing with DW 2012 here. So let's back this one up. Same thing. DC Nugget /backups. We'll call you AWDW.back. And hit OK, and hit OK. So we've got a couple of backups going. Let's let those finish and see how they're doing here. So it looks like our first one's almost done. It is done, looks good. And then our second one's still going. So what we can do then is just flip back to our availability group wizard, and let's hit refresh, and look at that. AdventureWorks 2012 meets the prerequisites. We can just keep hitting refresh until our other one is done, or we could just look at it. Let's see, where are you? There it is. It's close. Come on, 10%. There we go. Perfect. Hit refresh. We're good to go. So now let's check both of these and hit next. And now this has to be one of the coolest screens ever because we can configure everything about our availability group on these 4 tabs. So the first tab is going to deal with replicas. Where do we want our replicas to go? Well, let's hit add replica and let's add SQL Nugget 2. There we go. Let's add SQL Nugget 3 into the mix as well. And now we have our 3 machines set up. Their initial roles, our primary is going to be SQL Nugget 1, and then we have a couple of secondaries in 2 and 3. We can also say we want automatic failover to occur between our primary and our first secondary, 1 and 2. So these are going to be those role switching partners that are going to be on synchronous commit mode and have automatic failover. And then we can also specify if it's a readable when it's in the secondary role. And we're going to specify those as no. We're going to drop down our third one, though, and choose read intent only. Now, if we did want our secondary to be readable, then we could, when it is in the secondary, we could just turn it to yes, and that would allow connections to come in and read data out of here. But we're just going to choose no for our first two, because whenever they're in the secondary role, they're purely going to be there for failover purposes. But our secondary role for our final one, our active secondary here, is going to be read intent only. So now anything with a connection string of application intent equals read only can get redirected to our what we're going to be calling our read-only database, our reporting database and such. Now the next tab has us configure endpoints. And the good thing here about running our service accounts, our SQL Server service accounts on each machine under a domain account, we don't have to worry about setting it up. The wizard's going to do it for us. So it's going to create 3 endpoints, 1 on each machine, all on port 5022 for the TCP protocol. And if you scroll over here, it's going to show you the endpoint name. It turns encryption on by default for us and then gives us the account that all of our services are running under. So this is nice, but keep in mind if you're not running your SQL services under domain accounts, then you will need to do this part manually using Transact SQL. But for here, it looks good, so we can head over to backup preferences. Now, this is also a nice thing about your active secondaries, is that you can run backups on them. So we can take the load further off our production database and just run them on our backups. So we can run it here. We can prefer secondary, which if there's a secondary available, it'll use it. If not, it'll do it on the primary. You can specifically say, I only want to run backups on the secondary only. You can choose primary, or you can say any. Let's just choose secondary there. And then down here, you can also put a weight towards which instance you would like to favor over other instances, or you can exclude an instance entirely from backups. The last tab here is your listener. So if you do not create a listener now, this is where I was mentioning in the slide where anyone that wanted to connect to our availability group database would have to do so by knowing what the primary instance is and connect directly to it. Also, for read-only routing, though, we're going to need an availability group listener to do that routing. So let's choose create an availability group listener. And let's just call this, how about our Nugget AGL. Nugget Availability Group Listener. The port you're going to want to put this on is 1433. That's where client connections come into, so you'll want to do it. A lot of people confuse this and put the port that our endpoints are on, and you won't get read-only routing to work if you do that. So leave it in port 1433 so it can redirect those client connections. And you can also choose static IP or DHCP. Let's hit add for a static IP, and let's just call this 100.3. Almost there. The final screen is going to have us specify how we want to get those databases up and running on our secondary nodes. So we can do full, which will do it for us. We just need to specify our backup directory, and then it'll create the backups and the log backups, and it'll actually use our full backup that we already created. So we'll just do a log backup and then restore them on SQL Nugget 2 and SQL Nugget 3. We could do a join only. This you'll use if you've already done that whole process yourself. You've already done a restore from a backup onto your nodes, so you can just join them into the availability group, or you can just skip it in case you want to do it at a later date. And we'll hit next. And the final screen is just going to take us through some validation steps, and we're good to go. Everything looks configured accurately. Now, the one thing I do want to point out is make sure that where your MDF and LDF files, that path is the same on your other machines. So I actually have ours, just to show you real quick here. I made a support files directory here in the local C drive, 70-462 support files, 20-AlwaysOn AG, and then we've got some files in here we're going to work with. But here is the data in the log files. So I had to make this same directory on SQL Nugget 2 and SQL Nugget 3. Otherwise, when it tries to restore the backups and those don't exist, you'll have problems. So you won't even pass validation if that's the case. But we look good here, so let's hit next. It'll give us a summary of everything going on. If we hit finish, it's going to bring it up online, configure everything. You can hit more details to watch all the steps that it's going to go through. I'm going to pause the Nugget here and let it run through it all. I'll be back when it's finished. Hey, look at that. We completed successfully here. We do have one warning that our quorum vote configuration isn't up to par here. it's not recommended for this availability group. So we could go back and reconfigure our quorum on the cluster to include file share nodes. Right now we're on a node only quorum configuration, but not a big deal for the demonstration. Everything else looked good. So it created all the endpoints, created everything, restored our databases, and then added them or joined them into the availability group. So let's hit close here. And now we can head up into availability groups, and here it is. So we can tell that SQL Nugget 1 is currently the primary. If we expand this, here are all of our replicas. So we have SQL Nugget 1, SQL Nugget 2, SQL Nugget 3 is second, SQL Nugget 2 and 3 is secondaries there. And if we scroll down and just check out what's on these, you'll see that we can see them on the other servers, and they're both, one of them is synchronized, and then SQL Nugget 3 is currently synchronizing. Now, let me just show you a couple of places for administration purposes. For instance, the endpoints. If we head into server objects, endpoints, here is our, under database mirroring, here is the endpoint that I created. So this endpoint will be on every instance. All right, and also then inside of underneath our availability groups, you can manage your availability group by right-clicking on it. You can add a database to a replica. We can add a replica to an instance, or we can add another listener. Let me just hit show dashboard. This is kind of neat. This is a nice overview of our availability group. So you can see all of our replicas, their role, the failover mode, the synchronization state, and then down here, failover readiness will tell us that there'll be no data loss between SQL Nugget 1 and 2 because they're in a synchronized state. Where if we needed to fail over to SQL Nugget 3 for whatever reason, we would probably suffer some data loss because it's in a synchronizing state and set up for asynchronous commit. Also, if you want to look at and do anything that we did in the wizard and change it, you can right click on the availability group, head into properties. Here is our general, where it just tells us databases, another area that you can add more databases into. But down here are all of our replicas. You can see their current roles. You can see their availability mode. SQL Nugget 3 automatically picked up asynchronous. These two are synchronous. Here's your failover modes. And then also connections while they're in the primary role. This is something, especially since we have a read intent only going on here with our third one, that we'll want to take our primary one and choose only allow read-write connections. That'll ensure that no read-only connections hit those databases. Readable secondaries, we talked about that. There's your session timeout and your endpoint URLs. Everything looks good. You can also mess with your backup preferences here and then also give permission to the availability group. So we'll hit OK. Other things you can do here is we can expand availability databases. You can see the databases that are involved and what their current state is, and you also have your listener down here. In fact, if you right-click and head to properties for your listener, you can see you can reassign the port and the IP address if you need to. So where do we go from here? Well, normally, if we wanted to work with our databases, we would connect to it, to the database engine, and right here we would specify our instance name, connect to it, and start working with our databases. Well, that's fine for us in Management Studio because we'll probably know what the primary database is. But let's say our users and our developers and our report writers that all connect through connection strings, rather than have them type this, and we can have them type in the availability group listener name. By doing it this way, the group listener will know which one is the primary instance. So if we didn't do it this way and failover occurred to SQL Nugget 2 and everybody has SQL Nugget 1 in their connection strings, well, that's a big job to run through and change all the connection strings and have clients restart their applications and such. So we can do this in Management Studio as well, by the way. So let's just type in Nugget AGL, hit connect, and check it out. Now we have a connection to whichever instance, whichever replica is the primary. Cool stuff, huh? Now, not only that, but I have an application down here, speaking of connection strings and such, called AW App. Let's open this up. So I'll fire it up. This is connecting right into, again, whichever one is the primary instance, because I use Nugget AGL in the connection string. So if failover occurs between SQL Nugget 1 and SQL Nugget 2, it could happen all day long. No big deal. We're connecting to the availability group listener, which will route our request to the appropriate replica. Let's take this a step further. I'm going to right click on our .config file here, and I'm going to add into our connection string at the end of it. Let's just add in application intent equals read only. So we're saying anything that comes from this application is has a read-only intent, so it should be redirected to our third replica on SQL Nugget 3, you would hope, right? Let's open this up. Uh-oh. It's an availability group and does not allow read-only connections. So here's the thing. This could be a little bit tricky to set up because even though we specified in our availability group, and where to go, let me get up there. In our availability group, we specified read-only intent, read intent only. We did everything right, but SQL doesn't automatically configure read-only routing for us inside of here. Yeah, maybe we'll get that someday, maybe in a service pack, maybe the next version. But right now, there's no way to do it other than transact SQL. So what we need to do is embed a little more intelligence into our availability group listener and our replicas to configure what's called a read-only routing URL. Because we could tell by that error message that it was redirecting it to our primary, which doesn't accept read-only connections because, as you just saw here, the only thing that accepts true read-only connections is SQL Nugget 3. So that's how we can tell from that error message that it tried to hit SQL Nugget 1 or SQL Nugget 2 to do that, actually SQL Nugget 1. So I have a script. Let me go down and get it here called read-only routing. Let me just drag this over here into Management Studio. And what we need to do then is, and I added all three here just to show you how to do it. We only need it on one because we need a read-only routing URL on SQL Nugget 3. So we're going to alter our availability group, modify our replica, and on the secondary role, which is going to be our SQL Nugget 3, we're going to set up a read-only routing URL. So I'm just going to do this anyway for all of them, just to get it in there. And so that's going to set up the URL. Now, once that's set up, it's still not ready to go because we need to then configure our primary roles to have a read-only routing list. So what we're going to do is modify SQL Nugget 1 when it's in the primary role. It's going to read-only route to SQL Nugget 3. And then when SQL Nugget 2, if it's ever in the primary role, it'll also read-only route to SQL Nugget 3. So make sure that you set up your routes on all of your replicas that may be primaries at some point. So we'll do that and we'll hit execute. And now also down here I added some DMVs just for troubleshooting, just to run through these here. This will just show your availability group, pretty much everything we did in the wizard there. The good ones though are going to be your replicas. So this will give us an idea of all of our replicas. It gives you your endpoint URLs, and then more importantly here, your read-only routing URL at the very end. So if this is ever blank, you'll know why your read-only routes aren't occurring. And then you have a couple more DMVs here for working with group listeners and your read-only routing list as well. So did that fix it? Let's find out here. Let's cross our fingers, open up our AW app with application intent equals read-only. Hey, and check it out. It worked that time. And another way to see if this worked, let's head over to SQL Nugget 3. Let's right-click, open up Activity Monitor. We should see a connection in here from our AW app. We should have, there it is, .NET SQL Client Data Provider. That's it. So everything's working accordingly now. Now to really complete this picture, let's say that our application is a data entry application. So let's close out of it because we would then want our data entry applications to work with our primary database as they normally would. So let's take application intent equals read only right out of here. We'll save the config file and then we'll launch it once again. And this time it's pointed at our actual primary replica. So no read-only intent. It's not getting redirected. It's right against our primary database where it should be. And now what we can do is give our report writers or anything else that has to do with read-only operations, we could tell them to put in their connection strings this application intent equals read-only. So I happen to have a reporting services project here with a report in it. And let me just get our view down here to view the report data where we have our data sources. Here's our data source. I'm just going to right-click, go into properties. And now I put application intent equals read-only. We do need to change this, however, to Nugget AGL. Hit OK. And now if we hit preview, this is going to go against our SQL Nugget 3 read-only intent replica. There it is. Pretty cool, huh? So that would really be the right way to design this. All the reports, application intent equals read-only. If we do have applications that do strictly read-only operations, then we could give those developers the connection strings. But certainly the best way to one of the coolest features in SQL Server 2012 is the fact that we can take all this read load off of our primary databases and move them onto secondary databases. Very cool feature there. And by the way, you can mimic that functionality in Management Studio. If you head down to Connect Database Engine, type in the name of your availability group listener, go to Options, Additional Connection Parameters, and type in application intent equals read-only. Once you hit connect, there you go. Now you'll be connected to your read-only replica. Now the last thing I want to show you here is how to perform manual failover. Pretty easy. You can right-click on the availability group, hit failover, and now we have a failover wizard. We can select next, and now we can choose what instance do we want to fail over to? And it'll show us here that we'll get no data loss, although we do get one warning here. Oh, it's just about our quorum vote, not a big deal. But it's showing us that there'll be no data loss if we go over to our automatic synchronous commit failover instance. But if we needed to fail over to SQL Nugget 3, there is data loss potential, and then we'll get a confirmation dialog box just to do that. But let's say we wanted to fail over to SQL Nugget 2, we can just hit next. We'll need to connect here, hit connect, choose next, hit finish, and now it'll actually do the failover and push us over to SQL Nugget 2. So this kind of stuff, manual failover, obviously you'll want to do if we needed to do something on SQL Nugget 1. If we needed to do any sort of upgrades or changes, then we could do that and fail over to SQL Nugget 2, make those changes, bring it back up online, and then if we wanted to, fail back over to SQL Nugget 1 in case we need to do the same thing on SQL Nugget 2. So we can just do all this role reversal stuff all day long, but now we can see that SQL Nugget 1 is secondary, and SQL Nugget 2, if we expand availability groups, is primary. And now you want to see the ultimate of cool. Let's open up our AW app. All right, everything looks good. We're browsing data, right? Everything looks great. Okay, let's switch back here. Let's do another failover, only we're going to fail them back. Switch role reversal here, so SQL Nugget 1 will be the primary again. SQL Nugget 2 will go back to the secondary. That doesn't accept any connections because it's not an active secondary when it is a secondary. And so when this is done, we should just be able to hit refresh in our application, and it'll look like nothing ever happened to the user. They'll have no idea that failover occurred. So let's hit refresh. Hey, how cool is that? And that's all the availability group lists are doing that. If we didn't have that in place, we wouldn't have been able to do this stuff like this. The connections wouldn't be redirected to the current primary replica. So really neat stuff. This is just awesome technology here in SQL Server 2012. In the CBT Nugget, we learned how to implement always-on availability groups. We started by getting familiar with the technology. We saw that an availability group is really just a set of databases that we can put inside of a replica that we can spread across multiple servers. So it's really just a copy of these databases spread across multiple servers that we can then use for high availability and disaster recovery purposes. We also got familiar with the requirements. We saw Windows Server failover clustering is a big part of these always-on technologies, and then we got familiar with all the components that make up an availability group. Everything from primary and secondary to read-only replicas. We talked about availability groups themselves and availability group listeners and how clients could connect to primary and secondary instances. And then we got familiar with how to do it. We jumped into a demonstration. We saw how to set up a Windows Server failover cluster, add nodes into it. We saw how to turn on always-on availability groups. And then we created, configured, managed, and worked with an availability group. I hope this has been informative for you, and I thank you for viewing.